thank you for opportunity, Cecilia, and hosting this. Thanks everyone for joining. Very glad to be with you online. And later in the year, I will be in Miami in person for those of you who are around. So looking forward to it. This presentation is introduction presentation to Microsoft Fabric and the benefits that it would bring to you as a Power BI developer. What would you gain from it? And we are not going, of course, to talk about all aspects of all aspects of Fabric. We are going to focus on a few of those. It would be a session with a lot of demos and not much slides. Yeah, and it gives you an overview of some of the concepts. We wouldn't go deep dive in some of these. If you have like some deep dive questions, I might guide you to some of the blog articles and videos that I have. And I'll let you know where we can have some discussions or questions, but I'll start with this anyway. Okay, about me, I'm Reza, Microsoft MVP for like, I don't know, some years and regional director. I blog at radacat.com and I have some YouTube videos as well. I have written some books. Feel free to connect to me in Radacat website and you'll get quite a lot of information over there. And you can also connect to me on LinkedIn and social media. Okay, that's pretty much all about me. Now, why Fabric? Let's start with that. Why Microsoft came with this project called Fabric? When you are in analytics space, there are many different technologies that you usually need to be aware of or work with. And each of these technologies have their own platform to work. They have their own licensing situation, which makes it complicated. Like Power BI itself would not be enough. Sometimes you combine Power BI with Synapse, with Databricks, with even with things outside of Microsoft, like Snowflake, things that would give you extra features that Power BI might not have, like Data Factory for data ingestion at scale, Power Automate to schedule your semantic model refresh after your data flow refresh, things like that. It's quite a lot of different technologies to work with if you are in a data analytics space, and that makes things complicated. Learning about each of these technologies, learning about the different portal, the different framework that you have to go and build the solution. In some of them, you have to go to Visual Studio to build the solution. Some of them you go to Azure Portal to build something. Some of them you'll go into like Power BI Desktop, build it, publish it to the Power BI website. So they each have their own platform. They also, each of them have their own licensing structure, which makes it quite complex, understanding how each of these, their licensing works. And then if you want to use 3 or 4 of these services, it would cost a lot and it would be quite a complex licensing structure. So all of that complexity, Microsoft thought, well, how can we reduce that complexity? So they come with this this idea of Fabric. The whole idea is to simplify that process. If you want to do data analytics project, we will provide you a tool or a service that gives you everything that you need. And that would cover everything basically. So what Fabric really is combination of 3 major products from Microsoft: Data Factory, Azure Data Factory, Azure Synapse, and Power BI. These 3 products pretty much gives you the entire like full stack of a data analytics. They are all cloud-based solutions. Because of that, this is also called software as a service, cloud application, or SaaSified data analytics platform. Using Data Factory, you get the data, do the data transformation. Using Synapse features such as warehousing engineering, you can perform like data warehousing actions at a scale in a high performant backend of a Spark engine. You would be able to perform data science using notebooks on top of that, real-time intelligence, and Power BI, of course, to do the visualization, the insights, that part of it. And all of these is powered using one storage framework called OneLake, which is like a logical storage across the whole tenant and can be accessed quite seamlessly. It would be a place for all your data, basically. This can be governed with Purview, but Purview is not really part of Microsoft Fabric licensing. It's an extra thing to purchase. And in Microsoft Fabric, AI agents are also used in different places. Like, for example, we have Copilot in Data Flows, Copilot in Data Warehouse, Copilot in Power BI. So that is all the Fabric, basically, like very quick introduction. Now, that was pretty much all of my slides. We are going to do a bunch of demos. I'll start with what is a lakehouse. I'll show you how it works. We'll build a solution that would eventually lead to a Power BI solution, but I'll go through these different components. We'll talk about lakehouse. We'll talk about data flow Gen 2, which is different than data flow Gen 1. We have the data pipeline features that it would bring, shortcut, Delta Lake table, custom semantic model of Power BI with direct lake connection. So we'll talk about all of those and see how we go. Okay, so let's start. Here I have a workspace that this workspace is associated with the Fabric capacity. And I'm going to start with first going to my Fabric portal. So as you see, Fabric portal and Power BI portal are basically the same thing. I'm actually in app.powerbi.com, but because I have Fabric license, in my case, it is a trial license, I see all of these Fabric workloads, we call them. You can call it module or workload, whatever it is. Each of these gives you different abilities. For example, Synapse data engineering or the data engineering parts of it would give me some objects creation. One of them is a lakehouse. Now, what is lakehouse? Lakehouse is a term that is generated from two terms, basically. It comes from data lake plus data warehouse. When you combine these two together, it becomes lakehouse. It's a place that you can store structured data, like tables, like a database. And you can also store files. In case you need files to be close to your database tables, you can do that using Lakehouse. So instead of, for example, saving your files in OneDrive for business and then saving your tables in Azure SQL Database, what you can do is to have a Lakehouse, save files and the database tables, all of that in the same place. So I'll go to the lakehouse and let's go and create one. Let me actually create a new workspace because it would be much more cleaner in a new workspace. Yeah, I have quite a bunch of items in this workspace already. So let's call this Power BI times workspace. And this is going to be with my trial account. Now I'm using my trial account. I'm at the moment in a hotel in Sydney, so the performance might be a little bit slow. It doesn't mean that the performance of Fabric is slow. It is just like the hotel internet connection and the trial account that is also used with some others. Okay, so here I'll go ahead and start with creating a lakehouse. I'm going to call this lakehouse Adventure Works Lakehouse. Yeah, Adventure Works Lakehouse, Power BI times, right? Quite a long time, long name. Anyway, the Lakehouse, consider it as a database, but a place also that you can store your files. So this window I'm in at the moment is what we call Lakehouse Explorer. In Lakehouse Explorer, I have the tables and files, so I can have both of these. I'm going to load this data into this from an Excel file. I have an Excel file in here, which I'm going to copy that link. And the way that I want to bring that data into here can be using different approaches, using shortcuts, using uploading a file, pipeline, things like that. I'll start with data flow Gen 2. If you are not familiar with data flow is like Power Query in the cloud. It is a data transformation engine separated from Power BI. You can connect to all sorts of data sources that are available, like over 200 data sources, get the data, transform it, load it into a destination, which in this case can be our lakehouse. It uses Power Query behind the scenes. So what you see right now is basically Power Query editor online. For those of you who worked with Power Query in Power BI Desktop, this is pretty much the same thing. Some minor differences, but it's pretty much the same apart from that. So let's call this data flow Adventure Works, and I can get data from a source. Similar to all the Power BI situation, it could be any sources. most of the sources are available here. In this case, I'm getting data from an Excel file, which is using this link. Did I copy that link? I don't think so. Copy link address, paste it here. Okay, here it is. Again, similar to Power Query within Power BI Desktop, this will scan your data source, will show you the sources, the tables that you have over there. I'm going to select customer table, product category, subcategory, and fact internet sales. Just a bunch of tables. And then create. This bit is familiar for you if you already worked with Power BI data flows. However, this is a data flow Gen 2. One of the big differences in data flow Gen 2 is that the fact that we have data destination. I'll enable zooming so that when I go to that part, you'll see it a little bit better. This data destination is one big difference between Dataflow Gen 2, which I'm creating, whereas Dataflow Gen 1. And Dataflow Gen 1 automatically saves it as a CSV file within Azure Data Lake Storage Gen 2. This saves it over there, but it also has the ability to save it in a Lakehouse, Warehouse, Azure SQL database, and KQL database. Anyway, I'm going to do some simple transformations here, and then once the transformation is done, we'll load it into that Lakehouse. So this is like a data flow editor or Power Query editor that you worked with previously. I'll go to the diagram view. Here I see these in a nicer view in a diagram style. I'm going to flatten these three tables together, product, subcategory, and category. So I'll start with the dim product and merge that query as a new query with dim product subcategory based on product subcategory key in both of these. I can choose the type of merge if I want. In this case, I'll just leave it like that. This would combine those two tables together, and it should also show me here a nice diagram view of how they are merged together. The merged would have all the columns from the first table plus a sub-column list from the second table, which I'm going to only select a few of these columns. The product key is what I want, the product name, and this subcategory that is generated after the merge. So remove other columns so that we keep only these columns. Every transformation step that I do here will be added in here, and it will be also added in the query settings. Behind the scene, it will generate the M script. I'm going to expand this and say I want product subcategory name and product category key, because I want to use that to then merge it with the product category as the next step. So far I have merged the two tables together. Then the next step is that I'll go and say merge queries and merge it this time with product category based on product category key, click OK. Kind of similar process. What I'm basically doing is to flatten these three tables together. You see they are all combined to merge and create this. Now the last step, I'll expand it, get the product category name, and then I have all the columns that I need, which is product name, subcategory name, and category name. I don't need category key anymore, so let's get rid of that. These null values that you see here, these are not because of something is wrong. If I scroll down, you see some products with category and subcategory. Not every product has category or subcategory, so that is why you see some null values over there. So this is what I have done to create my product table. Let's rename this and call this product table. Now that I have the product table, I want to make sure that this product table goes into that lakehouse that I created as a destination. And that destination is already here. You see, it is already having that lakehouse as a destination. The reason is that when I was in that lakehouse, I started creating Dataflow Gen 2 from that lakehouse. I can change that. I can say, I don't want this destination. I want a different destination. I'll just go through that process very quickly so that you see how it is. So when I have that destination option, I can go and choose the destination type, lakehouse. And then I would be able to go and choose where that lakehouse is. like I'll select the warehouse, I'll select the workspace that includes that lakehouse. In this case, it was called Power BI Times workspace, and under that I have this lakehouse. And there is no product table over there, so it is going to create that. If there is an existing table, you would have the option to say append this data in there, or just for example, replace the existing data. I'm not going to do any of those configurations because this is a new table, so I'll just save it like that. Taking a little bit of time. Okay, now it is saved. Now for all other tables, this is automatically done. I don't really need to do that. Even for the product table, I didn't need to do that. I just went through that process so that you can see how simple it is. What I don't want to happen is that I don't want the product category, subcategory, and the original product to get loaded into the lakehouse because I have combined them and I created this product table. So what I'll do is I'll go to these and then remove the destination for them. This is basically similar to what we have done in the past in Power BI Desktop, like a disable load. This is something similar to that. You are disabling the load of these into the lakehouse, but they are still part of the flow of refreshing the data, right? So as a result of this data flow, I should have customer table, fact internet sales table, and product table loaded into the lakehouse. I'll click on publish. When I publish, this would save all of these changes, modifications that I've done in Power Query in different steps as a JSON file behind the scene. A data flow file is a JSON file behind the scene. So this is at the moment is saving all of those configurations. Once it is saved, then it would go and refresh the data. You can, of course, schedule this to be refreshed on a schedule basis so that you get the data up to date as it comes through. Okay, now I have to wait a little bit for this to get refreshed. While this is happening, any questions so far?
I see a few questions in the chat. Could you touch a little bit on about staging?
Staging. Okay, yes. The data flow Gen 2 itself automatically stages the data. What that means? It means that it would create a copy of that data into a lakehouse called the staging lakehouse. Automatically happens, which is a good thing, just in case, for example, the last data that gets loaded somehow missed, or somehow you missed some of the record, something happened on that, you still have that staging that you can get back to it. Creating a staging data structure is always something we recommend in any BI system. So this is basically doing that automatically for you. Okay. Okay, I think good
you
for
have an extra
now.
one.
Oh, yeah.
It says, when you save to Lakehouse, will you be able to use Lake Direct mode in Power Query? In Power BI, I'm sorry.
Direct Lake mode, yes. Yeah, we will get to that. Direct Lake is coming. So yes. Short answer, yes. Longer answer, wait a little bit until the demo for that. Okay, so the refresh is done. I'm going to the lakehouse. Let's see what is going on in the lakehouse. So let's just refresh the list of tables here. I should have the 3 tables over here. These are the 3 tables. If I click on them, I'll see the data of that table. This is the Lakehouse Explorer. It's a good place to see data within the tables and all of those information. You see there's a little triangle sign beside each table. This means delta. It's a format that these tables are stored. This is not like SQL Server database table. It's a different format. Delta is hosted by a Spark engine behind the scene, which I'll talk about it a little bit later. But for now, let's skip that. For now, this is the tables. All the 3 tables that I mentioned are loaded here. I want to see what this lakehouse looks like from the database point of view. I can use this switcher over here to switch from the Lakehouse Explorer to SQL Analytics endpoint. SQL Analytics endpoint is a place that I can work with the data of the lakehouse like a normal SQL Server database. So here, when I come to here, I'll see my database. whatever name it had, schemas. At the moment, I loaded everything in DBO schema. I didn't really create a new schema to do that. All the tables under that. I do have options to use views, functions, stored procedures, like a normal SQL Server database, basically. I can even go to the query tab at the bottom here and start typing a query here, like whatever SQL query you want, such as like select top 10 star from this product table. This could be pretty much any SQL queries. There are, however, some limitations in here. This is not exactly like the SQL queries that you write on a on-premises SQL database. Like there are things that you cannot do here, such as truncate table or merge command. This is supporting most of the things that you can do on an Azure Synapse warehouse, or most of the things that you can do in an Azure SQL database. There are some documentation of what is supported, what is not supported, but most of the things are supported, and you can sometimes find an easy workaround if something is not supported. Okay, so I can do this, or I can create visual query, which would basically use the data flow to do that query. Not only that, as a database developer, I might not really want to use this area to do my things. I might be more comfortable to use something like a SQL Server Management Studio. So what we can do is that we can go to the setting here. It comes with this SQL connection string that I can then go and open SQL Server Management Studio. Yep, this one. Let's open that. And connect to it like a normal database server, like a normal SQL Server database server. So, coming gradually. Okay, so let's paste this over here using my credentials, connect. And let's do the authentication, complete. Let's go back here. So the server name has that unique ID, whatever it is, but the database under that. Now, when you connect to there, you are actually connecting to that workspace, and that workspace might have a bunch of other things. Now, you see these staging options that I talked about, so automatically created and things like that. You can use them if you want, but you don't have to, right? In this case, I don't have anything to use on those, so I'll just go in my Lakehouse here, expand it so that I can show you where the tables are, and expand the tables, and I would see list of those tables coming over here, right? Like a normal database table, I can start doing my queries and things like that here. There is one limitation in the type of scripts that you write. You can write scripts that query the data, but you cannot update the data or insert the data or delete the data when you use a lakehouse object. If you have used a warehouse object, you could have done that. I have a separate video explaining what is warehouse, what is lakehouse, what is Power BI data mart, the difference between all of these three objects, like limitations that one have, the other one doesn't have, things like that. The object I'm using at the moment is a lakehouse. So lakehouse, I can read the data, but I cannot update the data using T-SQL. I can update the data using Notebook. I'll talk about that a little bit later. So this is the SQL endpoint of that. Now, before going further, I want to show you one other components of this Fabric environment. We talked about so far about the Lakehouse and about data flow. Now, let's say I want to run this data flow as a process. In that process, I want to first have a like a date time of the starting this data flow, and then run the data flow. If the data flow was successful, a date time of ending that data flow. And then if it was successful, sending a message saying that this is started at this time, ended at this time. I might even want to, for example, refresh my semantic model after that. So building like a control flow of the thing. And we can do that using using the data factory workload, using the object type called data pipeline. If you have worked with Azure Data Factory, this is similar to the data pipeline that we have in Azure Data Factory, but it is enhanced even more than that. So I'll go and create this data pipeline. And if you have worked with SSIS before, this is like the control flow of SSIS. So let's call this pipeline AdventureWorks. Create that. Pipeline basically is an orchestration tool. It gives you different activities that you can say, I want this activity to run after that activity and things like that. So let's get this opening. Here it is, my pipeline. I'll go to the activities. These are some bunch of activities you can use, like copy data, running a data flow, executing a notebook task, a script, like stored procedures, if-then structure, for each loop, calling another activity, a lot of things like refreshing a semantic model. There are many different activities you can use in here. I'm going to do a simple pipeline. So adding a data flow activity, here it is. And under the setting, I would choose the data flow that I want to run. Here it is. Before running this data flow, I want to set a variable. So I add this activity as a set variable. I'm going to call this set variable start. Then I'll go to the setting. I'll create a new variable. I call it start time. String type is fine because I want to add it in the email later, so a string would work perfectly fine. I want this start time to fetch the time, the current time from the system. So the value of that can come from a function. When I add dynamic content here, it has a expression-based language that I can use. It's not a whole language, it's a bunch of functions. But it is not M, it is not DAX, it is a different thing. So you have to learn a little bit about this, but it's not that extensive. It's really simple to learn. So in the functions, I'll expand date functions, UTC now. This basically means the date and time based on UTC time right now. I'll use that and adds it over here. Now, after this activity, I want the data flow activity to run. If you look at here, after each activity, we have a bunch of output states, which says on which state I want the next data flow, the next activity to run. This obviously means on success. This means on failure. This means on completion, which is either failed or succeeded. I don't care on completion of this. Just go and do the next one. This means a skip. Skip is a situation that this task supposed to run in some situation, but it didn't. Like it was in a if-then-else condition situation. In if-then-else, you have on the then side, you have one activity. On the else, you have another activity. Depending on criteria, one of them executes, the other one is skipped. So that is what the skip means, in case you need to use it. Right, so in here, I would just say after on completion of this, go and run data flow. I would add another activity here that says, here it is. So this would be set variable end. And similar to that, creating new variable end time. It is going to be still a string type, and it is going to be using the same date function of UTC now. And on success of this, I would go there, because if it wasn't successful, I don't want to get that variable. Now, if it wasn't successful, you might want to do something else. Like if it failed, you might come with a different error message and say, well, your data flow refresh failed. Or you might do something else, like run another data flow. Things like that. Or you might even say, if it succeeded, I want to refresh the semantic model and then go to set variable, right? You have all the flexibility you want to do here. I'm going to keep it simple. So just adding a email task at the end, or Office 365 Outlook activity, and saying that after this is completed, come here. Let's say I'll use my login, my account to log in here, so that this account would be the account to send the email. Hello, access. Now this email can be pretty much dynamic. Every part of it, the subject of it, the people that this email goes to can be dynamic, and the body of the email. Each of these can be dynamic content. So basically, it means that you can create a process in here that would send email to different people based on the data if you want to. But for me, I'll just do that manually for myself. And the subject, let's say pipeline executed. That could have been dynamic as well. And the body, in this one, I just use start time, end time, and some sort of message, right? So once this is done, I just check if there is everything correct. Yep, looks like validated. And then I would run this. Now, this could have been scheduled. And usually you want to schedule something like this. This would be where the whole ETL process happens. This is like your master pipeline that executes everything else. You could actually have like one master pipeline running some child pipelines, each of those pipelines running one or two different data flows, refreshing semantic models. So you can actually design it like the way that we previously designed SSIS packages or things like that. Okay, now we have to wait a little bit for this to run. In the meantime, any questions?
I see some questions.
Fine. Okay, let me see if I can also open it. What can you do with Databricks on ADF? So Databricks would give you Databricks activities, such as some data engineering capabilities, working with your Databricks objects and things like that if you use that. So basically related to your Databricks object. The other question, in addition to SQL, can you do DAX to query the lakehouse? You can, but you wouldn't use DAX to query the lakehouse. You would use DAX to work on the semantic model on top of the lakehouse. I'll create that semantic model and I'll show you how that is possible. Question from Aziz, are these three tables called managed tables? Every table that you create in here with this way is a managed table. Basically, all the tables are managed table. We don't call it managed table. That is like an old term, not really used much. We call them delta table. The only tables that are not managed are like external tables. They are tables that are not delta table, like tables that you have linked somehow. They are not delta tables, but we don't really use them that much. So to get the proper structure of the data within this environment, you need delta table, which are all managed tables. Okay, I think this should be done. Yeah, it is done. So we'll get to the question again when the next opportunity comes. So you see each of these activities shows like a monitoring when it started, when ended, things like that. This is finished, so I should have received that email. Let's just open my Outlook and see if it is there. If you see any other email in my Outlook, ignore them like you didn't see it. We are just going to have a look at that particular email, which is this one. Right now, I didn't really format that email as something in particular, right? You see, this is basically the start time, the end time, and some of the message that I put there, right? We could have, of course, do some formatting and made it much more understandable and readable and things like that, right? But for now, let's just skip that. I close my Outlook. Yep, close the Outlook. So this was the pipeline. Now let's go back to our lake house. The next part I want to talk about is shortcut. Yep, okay. As you notice, when I brought my tables in here, I did not bring the date table. The reason for that is that I do already have my date table in another place that I want to use that. So the idea is that I want to go and use that date table in here. For that, I can actually go and use a shortcut because I already have that date table in another lakehouse, in another warehouse within my Fabric environment. Because Fabric has this concept of OneLake, like which is accessible everywhere. It means that we don't really, if we have a table somewhere, we don't really need to duplicate the data of that table to bring it here. We can connect to that table directly using a link. Shortcut is like a link. So we'll create this link to that table without really copying it, right? So let's create a shortcut. Shortcut can be internal or external. External can be to sources outside of Microsoft Fabric. In my case, it is internal. So I'll select this. And I should select somewhere that I have a date table. I think this should have a date table. I'm not sure, but let's just give it a try. On the tables, let's see. Yep, here it is. There's a date table. I'll select that. Then next, and then create. So this is another lakehouse in another workspace that I have access to it, and it has a date table in it, right? And it comes here as a normal table. When I click on it, it should show the data. There is one difference here, one little difference that shows this little link icon on top of it, which others don't have it. And that is the only way you can say this is a shortcut. Otherwise, it looks like any other tables that you have in your model. Now, the data of that will be loaded eventually. Yep, here it is. Now, what I'm going to do is I'm going to switch to SQL Analytics endpoint so that you can see that from SQL endpoint, this actually looks like any other tables in our model. So if I go to the view, if I go to the tables, you see there is no difference in here. So this looks like a normal table within this lakehouse, but actually this is a table in another place. And you can work with it like a normal table in this database. You can cross-join these tables together, work with it like a normal table, bring it into your semantic model, and it acts perfectly fine. There wouldn't be any performance problem because behind the scene, it is a table in the Fabric environment like any other tables, right? This is a concept of shortcut, which makes a big difference in terms of not duplicating your data. Definitely something to consider. And I like on each of these topics I'm talking about, there is a separate video I have. You can go and learn more about it if you want. Before talking about the semantic model and Power BI side of it, I just want to show you something else. The structure of Lakehouse or Warehouse behind the scene, they are not using SQL Server database engine. They are using a Spark engine. A Spark is not a Microsoft technology. A Spark is an open source technology. It is used in Microsoft, but it is also used in Databricks. It is used in many other places. Why Spark is used, why it is an important technology. Spark is a parallel processing engine for big data. Like when you have petabytes of data, where SQL Server might require quite a lot of performance tuning to work, something like Spark would work really fast, right? The way that Spark works is like all sorts of documentation. You can actually go and search for Spark, and there are websites that has those information about it. One of those is that the structure that the Spark saves the tables, that structure is called Delta table or Delta Lake table. Yeah, pretty much that name. But don't get that concept mixed with data lake. That is a different thing. Delta Lake is the format that these tables are stored. Delta Lake format or Delta format is that triangle sign that you see here. It's an open standard format. It is used again by Microsoft. It is used by Databricks. It is used by many others. How does this work? I'll show you the file structure behind this. So if I go to the fact and sales table, for example, and if I go and say view files, you would see a bunch of files in here. They are all with the extension of Parquet file. And then there is a log folder that has a bunch of JSON files. So what are these basically? Parquet files are the data files. This is where the actual data is saved, like a CSV file. When we have data in a CSV file, that is a format of storing data in a file. Parquet is another format of storing data in a file. There are a lot of big differences, however, between CSV and Parquet. CSV, when you open it, you can read it. It's like human readable. Parquet is not like that. CSV is row-based structure, whereas Parquet is column-stored structure, so that it would store your data efficiently. If, for example, you have redundant value, it would reduce that, which makes the size of the file much smaller when it saves it. So if you have a CSV file which is like 100 megabyte, if you do that as a Parquet, if you save it as a Parquet, it might be less than 10 megabytes, right? It depends on a lot of factors, but the write process of that is much more efficient. Not only write, the read process from that is also much more efficient because it is stored in a column store format. It is stored in a way that is good for analytics. So basically, Parquet is better for writing, better for reading. So then why not use this format to store the data, right? That is why Spark using this format of storing the data. This gives you all the abilities that a normal transactional database gives you, such as, for example, create, update, delete, all of those like things that you do on a data table. Not only that, it gives you a lot of other things. One of those things which can be really interesting is a feature called time travel. Time travel, it's a big topic itself. Again, I have a separate video I have about this. Basically means that this delta structure will save information about when data has changed and what was that change, which is really cool for when you want to know the status of this data at a specific point of the time. Like, for example, you wanted to know this sales table yesterday, this time, what was the data in the sales table? Because the data got updated in let's say, the last 24 hours. Time travel will give you that ability. And the way that it does is using this bunch of Parquet files. Every time you make some changes, it might generate new Parquet files. And then in the log table, in the log folder here, it creates new JSON files. These JSON files have some information such as, for example, saying that this is the new file added and this is the modification date time. This is how it associates that what data is changed at one point of the time, right? And there are some SQL codes that you can use to retrieve the data as that point of the time, like creating a getting a timestamp of your data from Power BI point of view. Now, we wouldn't be able to do that demo in this short time, but I have 2 separate videos on time travel in YouTube channel, Radicad. You can go and check it. Now, the reason I'm talking about all of these is that I want this to lead into the topic of direct lake, which I'm going to talk about. Because the data is stored in Parquet file and it is stored in columnar store format, it opened up a new opportunity for Power BI to work with this data directly. When you have Power BI solution, when you go and connect to a source, there are different types of connection modes, right? You can say, I want to import the data from the source. I want to do direct query, things like that. When you do import, you are basically creating a copy of the data from that source, bring it into Power BI proprietary format, file format, whatever it is. And that proprietary format actually saves it in a columnar store structure because then it can read it faster. That is what Power BI does behind the scene. With situation like this, when it reads data from any of these delta tables, that is in Lakehouse, in Warehouse, in a KQL database, then it is unnecessary to do something like that because the Parquet file is already columnar stored, right? What is the point of connecting to it, copying that data, bring it into another file and saving it as a columnar store, right? It's already columnar stored, right? So Microsoft team did some changes in the Vertipack engine so that Power BI, when connected to files like this, it considers these Parquet file as its own proprietary file. So from Power BI point of view, these are the Power BI files to work with. It is already connected to your database tables. This also means that it doesn't need to refresh the data because this is already where the data is. As soon as your data gets updated, your Power BI file, your Power BI report would show the new data. So in fact, this is a new type of connection that is available here called direct lake. Direct lake is Power BI direct connection to these delta tables, to the Parquet files under the delta tables. It performs like import data, and now it's not exactly like that. Like there are milliseconds differences, things like that, but milliseconds difference is not really something to worry about. It is acting like import data, and it is like direct query. So it is fresh data, and that is what I'm going to show you right now. How does it work? So let's go to our SQL Analytics endpoint. Okay, here you are in SQL Analytics endpoint. These are our tables. With the SQL Analytics endpoint, with the Lakehouse or with the warehouse object, there is always a semantic model, a Power BI semantic model created. I see that in the model tab. Here it is. These are the tables that I had over there. Not only those tables, you also see some tables that I have not created, like these. These are what we call as DMV, Dynamic Management Views. Some views that gives you some information about how the performance of your warehouse or lake house is, like in the past 24 hours, for example. You want to know what queries took, how long it took run, and how many queries you had to run, and things like that, right? Some monitoring information. You wouldn't use them in your end user reporting, but you would create some reports from these to for yourself to monitor your warehouse or lakehouse. In this case, I don't want to do anything with those. I just want the 4 tables that I have created. Now, this is the default semantic model view. It gives you some modeling experience, such as creating relationships, things like that, even creating measures. But if you create a custom semantic model, it gives you much better functionalities. Again, I have a separate video about why custom semantic model whereas default semantic model. But in this case, let's just go and do that. I'll go to here and create a new semantic model. So this new semantic model I'm creating, let's call it semantic model Power BI times. And I'll select all the tables that I want there. So even that linked table, that shortcut table, can be used exactly like any other tables. I'll confirm that. This would now go and create a new semantic model. Still using direct lake connection because these tables are data lake. That blue stripe you see on top of these tables, that means direct lake basically. And it automatically is direct lake. If you don't want direct lake, if you want to import, you can do that. Or if you want to do direct query, you can do that. But the default type of connection with these is always direct lake. So the new semantic model is generated. Let's wait for this to come up. Okay, here it is. The new semantic model is generated. As you see, this is like a model editor in Power BI Desktop, much better model editor when you use that custom semantic model. It gives you ability to create calculation groups, measures, row level security, all of that. But we want to keep things simple. So what I'll do is I'll connect this to the product table using product key, the relationship, then I would connect it to customer table based on if I have a customer key. Yep, here it is. So that is done. And then to the date table, let's say I just do that based on order date to date. We could have used date keys as well, but I just kept everything simple. Not only creating these relationships, you can also do things such as, for example, you don't want this column to be visible, make it hidden, select multiple columns and make it hidden, or select a particular column such as sales amount and change the formatting of this to be currency, for example. And do something like decimal places too. If you want to create a measure, you can do that. All of your tax expressions are fine in here. So pretty much everything, right? And that's it. Let's say I don't want to spend much on the semantic model. This is not a Power BI development session, so this should be good enough. The next stage is I'm going to create a report from this. So let's go and create a new report. And you see, I'm building everything in this experience. I don't even need to go to Power BI Desktop. So here, then I would go and build a very simple visualization. Let's say this shows sales amount in a cart visual. Now, because I want to show you this functionality of Direct Lake, I would get my report page to automatically refresh every second so that as soon as the data set behind it gets the new data, you see this. So I'll go to the report page, page refresh, turn on, auto page refresh every 1 second, right? This way I can get my report page automatically refreshed, right? Let's save this. I'm going to call this report. Oh, not there. I'm going to call this report auto refresh. Okay, now this is getting refreshed. You see there's a little refresh icon here. It's a report refresh, report page refresh, not the semantic model behind the scene, only the report. But if the semantic model's data gets changed, then this would update. In this case, because it is using direct lake, if any data in that lake house gets updated, this would show that soon after. Now, how the data in your lakehouse gets updated? Well, it can be done using SQL scripts. It can be done when you run your data flow or data pipeline next time, any of those. In this case, just for the test purpose, what I would do is that I would go to that lakehouse and I would update some records in that table. Now, I mentioned to you that you cannot update the records using normal SQL because it is lakehouse. If it was warehouse, you could have done that. Because of that, what I'll do is I'll go to here and I'll create a new notebook. Notebook is a place that you can even update the data in your lakehouse. Notebook is a data engineer object, a data scientist tool or object to use. Using Notebook, which is similar to Jupyter Notebook, we can connect to an existing lakehouse. So here I would connect to the lakehouse that I already have. And then we can go and write code in 4 different languages. So this is the lakehouse that we have here. I can go and write my code in 4 different languages. Notebook gives me ability to work with Python, Spark version of Python, which is not exactly like Python on-prem. It's different version of it. Scala, Spark SQL, Spark R. Each of these gives you quite a lot of different powers to do different things. Like, for example, Python is good for deep learning, R for analytics, SQL for working with data, Scala for big data, things like that. Again, I have a separate video talking about why Notebook, what are the benefits of it. In here, I just want to use Spark SQL and update this table. So what I'll do is saying that update packed internet sales, packed internet sales, set sales amount to something, let's say 3,400, something like that. So this basically means that every single transaction in that table would be this when I run this, right? And that report value, which is at the moment $29 million, after this should be a little bigger value, I think. Let's just run this. The notebook, when you run it, it would first create a connection, instantiate a connection to the Spark engine behind the scene. Creating that connection takes a little bit of time. Otherwise, this script itself would run really fast. So the time that you see at the moment is mainly to create the connection. Okay, still we are 29 million. Let's wait for this to run. Okay, it is running now. Should be finished fairly soon. Yep, done. Let's get back here. This should update fairly soon as well. Come on. Now, sometimes it updates pretty fast. Sometimes it takes a little bit of time, but we'll see how long does it take. I mean, I can refresh the report manually, but it should automatically have picked it. Apparently it didn't. Let me see if the refresh button is on behind this guy. Now, we talked about the fact that it doesn't need refresh, but there is a reframing going on. I'll talk about that reframing in a second. Let me just see if that is on. It should be automatically on. Sometimes it might not be. Yeah, it is on. So this should have updated. Okay, I'll just close the report. Oh, yeah, there it is. Okay, so it took a few seconds to get that value updated. It's not still, it's not real time, but it has done that without me refreshing the semantic model. And that is what the direct lake is. Now, direct lake has limitations. It's not something that you would totally replace with import data. Like the way that you do in row-level security is a little bit different in direct lake. If you want to use views, it would fall back to direct query, which would slow down depending on the capacity you use for direct lake. This might also cause sometimes exceeding your capacity and then fall back to direct query. For example, if you want to do composite model, that would fall back to direct query. So there are situations that it would fall back to direct query. But they are working on getting a lot of these limitations lifted. So direct lake is a new thing. It is getting updated as we speak. The teams are working on it behind the scene. Now, when I looked at the semantic model that I created, in the setting of that semantic model, there is actually a refresh setting. Now, we talked about the fact that this semantic model, when it is direct lake, it doesn't need refreshing. This refresh has a different term, actually. It is called reframing. When you get the data in that delta tables updated, new Parquet files generates. And new Parquet files, Power BI wouldn't know about those new Parquet files unless the delta table, those JSON file that has those metadata, tell Power BI that this is the new file, go and look at that, right? So it's not really refreshing the data, it's like pointing it to the most up-to-date Parquet file to go and use, right? This is what this refresh is about. When you have it on, then that delta lake table would inform the Power BI that go and use this most up-to-date Parquet file. It's not really a refresh. That is what we call reframe. Sometimes you might want to turn this off because your ETL process takes quite a lot of time. You don't want this reframing to happen in the middle of it when your data in the tables are not fully loaded yet. And if you turn this off, then you can do a semantic model refresh at the end of your data flow. After your data flow execution is done within the data pipeline, you can add a task that does the semantic model refresh. And it wouldn't be actually a refresh. It wouldn't take a long time. It would be just a reframing. So it would be really fast action. Okay, that was pretty much everything I wanted to talk about. As Cecilia mentioned, I am doing a course later this year, October, November, in some of the cities. It might be close to you. So cities that I'm going to do some Fabric courses are in Miami and Dallas in North America and Toronto. And I would have one in September in Zurich. At the moment, doing courses in Perth and Melbourne in Australia as well. So really looking forward to see you all over there. And if you want to learn more about Fabric, I have a YouTube playlist that you can use. I will share this slide with Cecilia. She can also send it to you as well. But these are QR codes that you can also scan and get it. And also I have blogs on this subject as well. That was pretty much it. Any questions?
Yes, I have a question. Can you hear me? Okay.
Yes.
So, what are the limitations that you've run into so far with Fabric?
Like depending on what you want to do, you might get different limitations. Like, for example, if you are using Direct Lake, because Direct Lake, for example, at the moment has some new features, it's a new feature and has some limitations, so you would have some limitations in there. Like, for example, you cannot edit the semantic model of Direct Lake within Power BI Desktop. It has to be done within Power BI Service. You cannot, for example, create calculated column in there. And I wouldn't really use calculated column. I would create my columns within data flow when it loads into a lakehouse or warehouse, right? So those are some sample limitations. But to be honest, these are just limitations that would be lifted very soon, each of them. And the benefits that you get on the other hand side are much more. I would usually go for all of those extra benefits that I get, because now that I have the Lakehouse, I can use Notebook, I can do my data science, machine learning model training using the same thing, same, let's say, capacity that I have, that I use that capacity also for Power BI. So you get much more benefits than limitations, and limitations get lifted soon.
So, are there any security limitations that you can think of? Collaborating, anything in that line?
No, nothing limiting you from what you already have in Power BI. Like at the moment in Power BI, you do row level security, object level security, column level security. You can do exactly the same thing over here. However, when we have this Fabric environment, the idea was that you don't apply those in the Power BI anymore. You just go and apply it in the, let's say, in your Lakehouse, and all of those configurations would flow all the way to the Power BI without you defining it on the Lakehouse and on the Power BI. That feature is called one security. You apply the security in one place and it follows everywhere. That is not available yet. but each of these components can have their own security applied, like the way that you do it in Power BI.
Okay. One last question.
Yes.
I worked as a Databricks developer in an Azure enterprise environment with Azure Databricks.
Right.
So Databricks is not part of the Fabric environment, correct?
That is right, yes.
Okay.
But there are some partnerships going between Databricks and Microsoft Fabric. If you have watched, for example, the Microsoft Build session that Arun OneLake did, they announced two important partnerships. One was with Snowflake, one was with Databricks. So that like the details of those partnerships comes later in the year. But the idea is that you would be able to like cross-use these two together. Like if you still prefer to use your Databricks for your data engineering and things like that, and use the Fabric objects to get like a direct shortcut to those without copying that data, and then build, let's say, your Power BI with direct lake connection on top of it. Those are the things that are coming.
Okay, that's what was confusing me, because I was hearing bits and pieces of that, and then I'm saying, well, there's no Databricks, icon.
Yeah.
Okay, appreciate it.
You're welcome. Hey, any other question? I can open Teams and see if there is anything else. Okay.
I see a lot of questions. I'm not sure if you answered them all already.
Oh, yeah, I can check that. So from Aziz, with direct lake mode, what are the cardinality available? All the cardinalities are available if you are talking about like one-to-many relationships and things like that. I haven't checked many-to-many relationships, and I don't want to check many-to-many relationships. It's a relationship that I would never use it anyway. So even if they make it available, I wouldn't use it. Limitations are those that I just already mentioned, which is like fallback to direct query situation that does happen. From Juan, does direct lake limit your DAX as direct mode? Does it, or compared to import mode? Well, the DAX part, not really. You can use most of the DAX expressions in the direct lake mode as well. However, sometimes you write your DAX expression in a way, like you write a measure in a really bad performing way that would cause a lot of processing happening behind the scene. That processing might then cause a lot of data to be evaluated, and that might cause your capacity limit reaching. And when the capacity limit reaches, then it would fall back from direct lake or import, whatever it is, into direct query. So it might cause something like that, but there is no limitation in functions that you can use. From Fernando, can you explain refresh semantic model? We already did that. Yep. And Rick, what can you do with data breaks in IDF? Yep, we already talked about that too. From Aziz, can you please talk about mirroring? Mirroring is a feature in a warehouse that basically means that if you have your data elsewhere, let's say, for example, you have your data in a Snowflake or in Azure SQL database, instead of spending a lot of time and integrating that data, bringing it into Microsoft Fabric, this is all happening seamlessly for you. So once you create the mirroring, it does all of that integration. It brings the first load of the data, and then using the CDC and using some pipelines and data flows behind the scene, it will load only the changes into the Microsoft Fabric, so that as soon as the data gets changed in those source systems, it comes into here. I have a specific video on mirroring as well. You can go and check that out. Any other questions?
Awesome. I was able to unmute everyone, so if anyone wants to use the microphone, please do. I see clapping hands.
Thank you. Thank you.
Yeah, it was a
Thanks.
great presentation. You included almost everything.
Yeah, we still didn't talk about real-time analytics or data science and things like that, but I wanted to focus mostly on things that a Power BI developer would use immediately. Can we use DAX query with Fabric? Yeah, like a normal Power BI solution, you can do that. Yes, of course.
Right. I will stop the recording just in case someone wants to ask something off the record. For the recording, thank you everyone for watching. And thank you, Reza, so much. This presentation was amazing. Let me stop.